So for Earth Geometry Paper 1, the questions are usually just around calculating the time differences, distance, speed, or time. Or sometimes they'll ask you to find the difference in degrees, or maybe give you the difference, give you the time difference, give you the position of one of the points, and they ask you to find the position of the other point. That is usually how questions come in Mathematics Paper 1 under Earth Geometry. Let me just transfer the questions from my laptop to the application. Otherwise, it's also a very simple topic. So those of you who are intending to not choose that question in section B, I would highly recommend that you reconsider and you also select this one in section B, because it is very simple, as you are going to see. Very simple question. Because even in section B, it's very simple as well. So section B, by the way, as I'm transferring the questions, I can use this time to recommend some topics. Section B, the easiest topics you can focus on are 1. Linear programming, 2. Trigonometry, 3. Earth geometry, and 4. Cubic functions. These are the simplest you can answer in section B, where you can even guarantee yourself to say, I can get for linear programming, you can get even everything there if you are smart enough. Remember, linear programming requires that you come up with a R region that requires drawing and all that. So possibly the examiner will mark your neatness there. So you can't really guarantee your 12 marks, but you know you can guarantee yourself minimum of 10 marks there if you do everything right. So linear programming, you can get all those. Then trigonometry, there's no neatness, so you can actually get all 12 marks in that one. Minimum also can be 10 if you've done the right thing. When you go to Earth geometry usually comes with a frustra. Okay, so Earth geometry will have like almost 6 to 8 marks, so you can get 8 marks from there. And then you go to cubic function. Under cubic function there, in case you're not asked to draw, you can get a 10 out of 12, considering neatness. If you're very neat, you can get 12 out of 12. If you're required to draw, if you're not required to draw, you can get 12 out of 12. But if you're required to draw, you can get 10 out of 12, depending on how smooth your curve is going to be. So the biggest challenge in Mathematics Paper 2 is time management. That is the biggest challenge for students. So that is why, if you remember in yesterday's session, I was telling you to say the easiest way to pass Math Paper 1 is in being strategic. You really don't need to answer everything to be able to get a distinction 1. You just need to be smart about it. Many people don't finish section paper 2. Why? Because the questions are usually too many, and you won't have enough time to answer all the questions unless you are really fast. Okay, I knew what I was doing. I went into the exam with my own target. The questions are targeted. I had gone through the questions several times. I was very ready for that exam, but I still didn't manage to finish. Okay, but I was strategic enough to still be able to get a distinction at the end. So what am I trying to say? What I'm trying to say is what I've been telling you people to say. You just need to be smart about it. Don't start stressing, start trying to cover everything. Now is not the time to shoot everywhere. Now is the time to pick your targets carefully and make sure every shot counts. Okay, don't waste your ammo anyhow. Gamers now understand that language. Your ammo, you have let's say you have only 10 bullets and you need to take out let's say 10 beds. You won't start wasting shots anyhow. you make sure that each shot counts, because you have 10 bullets, 10 birds to take down. So you have limited time remaining. You can't afford to be misusing your time trying to learn things you have not understood before. So better you focus on the simplest of things that you can easily understand, and then now you perfect. You become very good at those, so that whatever question paper you handle, you are able to answer the questions correctly. That is what will make you pass. So in case you are stressing, that tip is for you. Pick your questions and start perfecting. Because realistically speaking, right now it is not possible for you to cover the entire curriculum with this time that is remaining. Remember, grade 12 exam for all subjects, GCE actually, GCE exam for all subjects, the scope is from grade 10 to grade 12. That is 3 years. Grade 10 work, grade 11 work, grade 12 work. So it's not possible that one at fattening the cow on the day of slaughtering. You can't fatten that cow. It's impossible. How do you cover 3 years of content in less than 3 weeks? It's not possible. Okay, so realistically speaking, just focus on the major topics and then start going through them over and over again, so that when the exam comes, those questions have no choice but to be hammered by you. Okay, so that is that. Focus, don't just study anyhow. Okay, so under Earth geometry we have a few formulas that you're going to be using. Okay, we said there is calculation of time, right? When to calculate the time difference, TD, this means time difference. To calculate the time difference, we are going to say theta over 15 degrees. That is the formula for finding the time difference. And then there's this other formula for calculating speed, which is equal to distance over time. You can use this formula to find speed, to use this to find distance, to also find time. Just like we are using the same formula yesterday to find the area of the sector, the theta, and the radius. So there is no need for you to say, okay, since I'm now finding time, I need to make time the subject of the formula. So what do? I'm going to cross multiply there like that, so it will give me TS is equal to distance, then I divide both sides by S like that, then the S is cancelled there, meaning the formula for finding time is distance over speed. There is no need for you to do this. Okay, like I mentioned, you don't have time, you just need to be smart. So this formula is enough to find speed, distance, and time. There's no need for you to have a specific formula for each one of these. All right, so that's what we're going to be using. Okay, now let's look at some facts. Okay, when it comes to Earth geometry, let me actually put up a circle here for illustration purposes. The globe looks a bit spherical. Okay, let me put it somewhere here. Right, when you go to the Earth globe, up here you have the north, down here you have the south. This side you have west, on the right you have east. These two are very important when it comes to calculating time. Know where the east is and where the west is, don't switch them around. All right, when it comes to the globe, lines that run from north to south, what are they called? They are called longitudes. Longitudes. And then line that run from west to east, like this, are called latitudes. Latitudes or latitudinal lines. There is one special longitude which runs right at the center of the globe. Okay, this one is called the Greenwich or prime meridian. This one is called a special longitudinal line because it is always at what? 0 degrees. And then there's also another special line, which in this case is a latitude, sorry. This one is called the equator. Okay, only has one name, and it is always at 0 degrees. These are two special lines, the equator and the Greenwich meridian. Please know these lines. All right, sometimes I'll just tell you to say, given that the following points lie on the equator, they'll need you to pick something obviously relating to its position. Okay, or given that these 3 points lie on the Greenwich meridian or on the prime meridian, what is the time difference between these 2 points? Okay, so please take note of these special lines. Okay, then another fact is that the sun rises from the east, right? This is a known fact. The sun rises from the east and sets in the western side. Therefore, places that are nearest to the east see the sun first, since it rises from the east. So we are going with the notion that the earth is spherical and not flat. So flat earthers, if you are here, please, for you to be able to pass this exam, you need to discard that thought that the earth, or that argument that the earth is flat. The examiner here tells you to say it is spherical, and that is what you are going to use. All right, so if the earth is spherical, meaning the places that are nearest to the east compared to the west, these guys here see the sun first. That is how come football lovers, you find that you are watching football here around 03, you're watching Messi here around 03, and yet there where the game is being played, it is sunny, it is during the day. You're watching Ronaldo at 01, but kuno ni usiku 01, kweve kuja, maybe it's 14 hours or it's 9 hours. That is the whole idea. Okay, that is where the time differences issue comes in. Okay, you find your relative is abroad, you're telling them good morning, there it is actually afternoon or at night. So that is how come we are saying places nearest to the east see the sun first compared to places in the western direction. This is going to be helpful when it comes to calculating time differences, because you know to say, okay, you are going to check which place is nearest to the east. The one nearest to the east is ahead in time automatically compared to the other place. So if, let's say for example, here you have a point B there, and then you have another point here A, meaning if you compare these 2 points A and B, A is ahead in time because it is nearest to the what? Eastern. So the time at B is behind the time at A. However, when the 2 points, let's say you have a D here, when the 2 points are on the same longitude, remember I said longitudes run from north to south. Okay, you have this longitude here. If the 2 points whose time you're trying to compare are on the same longitude, their time is going to be the same. Okay, places lying on the same longitude have the same time. That is the principle. There's a question we're going to look at which actually uses that notion. So it is important for us to know that any places on the same longitude have the same time. So you find that mostly our time zone, if you check on your phone, the time zone is usually for Harare. It's the one that is nearest in Central African region. If you go to your phone or your laptop, you check, if you say set the time automatically, the time zone that will be automatically selected is Harare. Why? Because Zambia is seemingly on the same longitude with Harare. So that's how come the time is usually the same. To confirm, we can actually check what is the time in Harare right now, and then we can compare our findings with what the time is here in Zambia. Okay, so that is that. Places on the same longitude have the same time. Okay, then when it comes to calculating time, your focus is only longitudes. No wonder I said places on the same longitude have the same time. Why? Because our focus for time difference is only longitudes, right? Okay, now another undeniable fact is that 15 degrees is equal to 1 hour, and 1 degree is equal to 4 minutes. Okay, 15 degrees is equal to 1 hour, 1 degree is equal to 4 minutes. Why is this important? There are times you need to be able to maybe what is the difference in like you're trying to find the time difference between points, and then your difference in degrees is, let's say for example, 16 degrees. You know, to say 15 degrees is 1 hour, so you're going to have 1 hour. Okay, how about the remainder, the 1 degree that's going to remain? You also need to convert it to time, so meaning it's going to be 1 hour 4 minutes. That would be the time difference between those 2 points. That is how come this information here is important. 15 degrees is equal to 1 hour, so that is when you're converting degrees to time or vice versa. And then 1 degree is equal to 4 minutes. Okay, so when it comes to calculating the time differences, not really time differences, but the difference in degrees. So under difference in degrees, if you check your paper 2 Earth geometry, remember what I said, that it's also simple. If you check your paper 2 Earth geometry, the first question, they will always ask you to find the difference in degrees, either between 2 points on the equator, not really the equator, on a latitude or on a longitude. And this is the principle you follow. Using this principle, you can actually go and attempt that question, and you'll be able to answer the question. So this is the principle when it comes to calculating the difference in degrees, either for longitudes or latitudes. If the points whose difference in degrees you're trying to calculate are in the same hemisphere. Okay, in this first example, let's use the points A and B. Let's say A is on let's say it's on 20 degrees east, and B is on 60 degrees east. Then we have C here, which is on 40 degrees west, and D, which is on 20 degrees west. So here we're trying to calculate the difference in degrees between A and B. If the places whose difference in degrees you're trying to calculate are in the same hemisphere, what do I mean by same hemisphere? They are both in the eastern hemisphere. East east, west west, north north, south south. That tells you that these points are in the same hemisphere. Okay, in the same region. If that is your case, they are in the same hemisphere, you are supposed to subtract the smaller one from the bigger one. So you're going to say 60 minus 20, meaning the difference in degrees here is going to be what? 40 degrees. These ones here between C and D, you notice they are both in the same hemisphere, because west west is in the same hemisphere. They're both in the western region. So you're going to subtract, giving your answer as what? 20 degrees. Okay, that is for longitude. So these are representing longitudes. Now, what if they're in different hemispheres? Simply do the opposite. Different hemispheres simply means one in the east, one in the west. Okay, that is what it means. So here we have east, there we have west, meaning they're in different hemispheres. So what do? We add, giving us 80 there. 60 plus 20 is 80. Same applies here, east, west. So we're also going to do what? We're going to add, giving us 60 degrees as their difference in what? Degrees. Let us now give examples for north lines, like latitudes. So let's say we have A there. Okay, can you actually use the same? Let me just change these values. So we have let's say we have 20 north and north, and there we can have south and south. Okay, so you can see we have north north, same hemisphere. What do you do when they're in the same hemisphere? Subtract 60 minus 20, that will give you 40 as their difference in degrees. South south, same hemisphere. What do? You subtract 40 minus 20 gives you 20 degrees as their difference in degrees. Okay, what if they are in different hemispheres? Same principle again. When they're in different hemispheres, you simply need to add. Okay, so here what do you have? A is in the north south, different hemispheres. What do? You add, meaning you're going to get 80 degrees. Okay, how about there? South north, different hemispheres. What do? You add, giving you 60 degrees as your difference in degrees. Now we can now look at calculating time. Okay, remember I said the formula for calculating the time difference is TD, time difference, is equal to theta over 15 degrees. All right, this theta we are seeing in this formula represents the difference in longitudes for those 2 points whose time difference you are trying to calculate. Remember I said when you're calculating time, your focus is only on longitudes, so this theta will always come from the difference in longitudes for those 2 points. Please take note, this theta will always come from the difference in longitudes between the 2 points whose time you're trying to calculate, the time difference you're trying to calculate. So we can now go ahead and look at exam questions if we have no questions at this point. I'll give it a few seconds. If you have a question, you can raise your hand, then I'll give you an audience. Okay, it's clear. That's nice to hear. Well, let us now look at question 1. So question 1 says, coming from 2024 paper 1, written by the grade 12s. The diagram shows the positions of points A, B, and C on the Earth's surface. Okay, you have those points. All right, you have the north there, you have the south there. Okay, they've not indicated, but this is east and this is west, but usually you can pick it up from that longitude there. Okay, all right, we have those points there. So now when it comes to identifying the point, by the way, this is the order, right? Okay, remember, okay, we didn't cover coordinate geometry, but this is the order for the coordinates. You need to start with the latitude first, followed by the longitudinal coordinate. This is the order when it comes to identification of points. So let's try to identify this point C. What are the coordinates of point C? Okay, point C, where these 2 lines are meeting, this line and that line, that is where C is, right? So you check. Remember we said latitudes run from these lines. These are latitudes. Okay, the easiest way for me, I know it may sound weird to you, but it works for me. Okay, I always try to figure out ways in which I can easily master things. So if you compare this line and this one seems a bit longer in length, even if it's curvy, compared to that one. So since this one is longer, this is how I mastered to say these are longitudes, these are latitudes. Okay, there are only 2 variations here, latitude, longitude. So this long one, if you look at the word longitude, there is the word long. So I know to say the longer ones are what? Longitudes. Automatically I know the other ones are latitudes. So do what works for you, but this works for me. Okay. All right, so I'll check what is the latitude for this point. I know to say this one is a latitude. It is what? 55 degrees. By the way, usually latitudinal coordinates are plugged in right where the line is ending, on the right, usually on the right. But you don't know, examiners are funny people. They can change it, put here, and then people will be confused. So they say if you want to catch a thief, think like a thief. You want to beat the examiner, so think like an examiner. They always put here. They know we are obsessed with patterns. Then let's say they change, instead of saying 65 south, they put it this side. Okay, and then someone who is used to always seeing latitudes this side, they will think, but where are the latitudes? And yet they have been put here. Okay, so I know to say the latitude here is what? 55. So I'll say 55 degrees north, comma, what is the longitude? The longitude is this long one here. Okay, then you see this arrow pointing at that same one, which is 45 degrees east. So I've been able to identify those coordinates. Okay, how about this one here? This one, let's say A. Okay, what are the coordinates for A? I'll check. What is the latitude? Remember, the format is latitude first, followed by longitude. So the latitude is this one. It's also sitting on 55 north. So I'll say 55 degrees north, comma, what is the latitude? The longitude. So the longer one is this one, according to me. So that is 75 west. 75 degrees west, and I would have clearly identified those points. How about point B? What are the coordinates for B? Point B is this one here, right where these two lines are meeting. Okay, what is the latitude for that one? This one is 65 south. So I'll say 65 south, comma, what is the longitude? The longitude is this one here, which is what? 75 west. So I'll say 75 west. Okay, so that is how you identify points. Now let us look at the questions. So the first question is saying, what is the time at C? Okay, C is right there. When the time at A is 11:22 hours. What is the time at C? When at A here it is what? 11:22 hours. So first of all, we're going to do this one step by step so that people understand clearly. I don't want to leave anyone behind. So the first thing we're going to do is identify the points where A is. Okay, or I can simply say what is the longitude? Remember we said for time. Okay, I want people to know how to identify coordinates, so I'll pick leaving the latitudes. What are the what are the coordinates for A? Latitude is what? 55 north. So I'll say 55 north, comma, what is the latitude? The longitude, sorry, 75 west. Okay, and then we're asked to find the time difference between A and C. What is what are the coordinates for C? C is also on 55 degrees north. 55 degrees north. How about the latitude? The longitude, I don't know why I keep saying latitude. It's 45 where east. 45 degrees east. Okay, so the time at A is 11:22 hours. That is your time at A. You're trying to find the time at what? At C. So the first thing you're going to do is you're going to use your time difference formula. TD is equal to theta over 15. But take note that you need theta here. Okay, we said for time your focus is on the longitudes. So these are the longitudes, these guys here. Remember the format, latitude and then longitude this side. So that's your focus. So how are you going to find your time difference? You're going to check these 2 points. Okay, the longitudes for these 2 points whose time difference I'm trying to find. Are they in the same hemisphere or different hemispheres? So they are in different hemispheres because we have west and we have east here. Okay, so what did we say you do when the position are in different hemispheres? You're supposed to add. Okay, so I'm going to say 75 plus 45 to find the difference in degrees, which is going to give us the theta for that formula there. 5 plus 5 is 10, remainder 1. 7 plus 4 is 11. 11 plus 1 gives us 120. So meaning our TD will be equal to 120 everything over 15. So time difference will finally be what? Okay, remember this is paper 1, you have no calculator. So if you don't know that 15 goes directly into 120, you can reduce using a smaller number such as 5. You can say 5 there gives you a 3. 5 into 12 is 2, remainder what? A 2. Okay, 5 into 20 gives you 4, meaning you're going to end with 24 over a 3 there. Alright, okay, once you do that you can now divide. At this point you have no option but to know or to figure out that 3 can go directly into 24 how many times? 8 times. Okay, so meaning the time difference will be 8 hours. Okay, that is the time difference between these 2 points, points A and C. Now the final part is to figure out, okay, are you now going to add or subtract? So the next thing is you need to check which of these 2 points is ahead in time. Remember we said the sun rises from the east and sets in the west. So whichever point is nearest to the east is ahead in time. Okay, so A is here, C is here, this is the eastern side. Which one is nearest to the east? Okay, C is nearest to the east, meaning C is ahead in time. Okay, that simply means you need to add the time difference to this time you have found here for A to find the time at what? At C. I'll explain that again. Okay, you need to figure out which place, which point is ahead in time. The points we're comparing are A and C. Simply check which one is ahead in time. The one ahead in time is C, but we don't know the time at C. Remember, it's not known. We only know the time at A. So in order for us to find the time at C, which is ahead in time, we need to add the time at A to, we need to add the time difference to the time at A to find the time at what? The time at C. Okay, so meaning, what is the time at A? 11:22. What is our time difference? 8 hours. So now I'll take you back to grade 7. Remember when you are adding time. Okay, 11:22 hours is the time at C. The time difference between A and C is 8 hours. So you're going to do this and then you add your time. Okay, 2 plus 0 is 2, 2 plus 0 is 2, 1 plus 8 is 9, 1 plus 0 is that. So meaning the time at C is going to be 9:22 hours and you are done. Okay, I don't know if you have any questions at that point. Okay, seems there's no question. All right, by the time we solve a couple of them, this will sink in and it will become very easy to answer. That is my goal and my wish. Okay, we now come to the next question. A plane flies from A to B in 9 hours. Calculate the speed if the distance between AB is 7,200 nm. Nm means nautical miles. Nautical miles. So nautical is not spelled this way. Okay, but that way. So usually in paper 1, they usually ask you to find distance in nautical miles. And speed will be in knots. In paper 2, that's when they'll change. Distance, they'll say find distance in nautical miles or find distance in kilometers. But usually for paper 1, they usually ask you to find distance in nautical miles. Okay, so we go back to that formula that I gave you. Speed is equal to distance over time. And then I can use this. I can put a data table there. So they've said a plane flies from A to B in 9 hours. This is time, right? So you know to say my time is 9 hours. And then calculate its speed. So you know to say speed is unknown. If the distance between A and B is 7,200. So meaning your distance is 7,200. So plug in what you know. Speed we don't know. What is the distance? 7,200 over time is 9 hours. Okay, now you need to figure out how many times does 9 go into 72. Okay, here's the thing. How are you going to easily figure that out? So if you know 9 times 9 is equal to 81. Remember in the previous lesson, area of a sector, I told you to say you need to know this double digit multiplication. 2 times 2, 3 times 3, 4 times 4. These are important. Okay, if I know to say 9 times 9 is 81, if I subtract a 9 from here, meaning I'm finding 9 times what? Times 8, right? Okay, what is that? It's going to give me, so this will give me 7, that will give me 11. All right, 11 minus 9, that will be 9, 10, 11, 2 there. Okay, and then I have 7 there. So I know to say 9 goes into 72 8 times. Okay, do it the way that it makes sense to you. This makes sense for me. All right, because here even if you do it this way, you have no option. Okay, 72. However, there's a simpler option. I've just thought about this one. 72 over 9. You can reduce using a smaller number. What number can go into these two values? 3 can go into 9 3 times, into 7 twice, into 12 4. Okay, then you can say 24 over 3. Okay, 3 into 24 goes there what? 8 times. So you can get your answer from there as well. Just a moment. Let me just I'll be back in a few seconds. Hi. Sorry, I'm currently in class. I'm teaching. Is it urgent? It's not urgent? It's not urgent. Okay, good. I'll call you once I'm done. Okay, sorry about that. So either way, you would have figured out to say 972 divided by 9 will give me 8. Then you simply add the two zeros, so it will be 800 watts. 800 watts. They said calculate the speed. Whenever distance is in knots, nautical miles, your speed is going to be in knots, like this. That's how you spell knots. Okay, that is the SI unit for speed, knots, like that. Don't forget to plug that in, and we are done. We now come to question 2, which came from 2021 paper 1 GCE, and it says the diagram below shows the positions of towns A, B, and C on the Earth's surface. NACS is a prime meridian. Okay, NACS, this one here, this longitude is the prime meridian, and under they've even indicated a 0 here to say it is 0 degrees. The examiner here was lenient. Okay, if I was the one, I would just say it's a prime meridian, and I expect you to know that the prime meridian is always at 0 degrees. Okay, so that is that. What are they now saying? A ship takes 26 hours to travel from B to C, a distance of 1,560 nautical miles. Find the speed of the ship in knots. See, sometimes they'll say in knots, sometimes they'll just say speed. So you need to know the SI unit for speed. It is knots. Okay, so same thing, use the same formula. Speed is equal to distance over time. Speed will be equal to, what is the distance? They said a distance of 1,560. So I'll put 1560 over what is the time. A ship takes how many hours? 26 hours. So that is my time. Then I'll simply divide. You see how simple these things are. Again, there we have some big values. What can we use to reduce those values? We can use a 3, right? No, 3 can't go into that one. No, it can't. Let's use a 2. Okay, 2 into 26 will give us 13, right? 13 plus 13 is 26. 2 into 15 is 7, remainder 1. 2 into 16 is 8, meaning on top I have 780 over 13 here. Okay, now does 13 go into 78? Okay, let's try. Obviously this number goes into 78 directly, but let's try. How many times does 3 go into 78? So here's the thing. The number I'm going to use to multiply here, or here rather, I'm going to make sure that when I multiply this number with let's see, I'm trying to find 78, right? Okay, so when I multiply this first number, this 3, with that number, I need to find an 8. Like that answer should have an 8 at the end. I don't know if this makes sense. This is how I figure things out on my own. Okay, I'm trying to see how many times 13 goes into 78. So what number can I multiply 3 with, of which the last number will be an 8? I can multiply it with 6, because 3 times 8 is 18, right? Let me try 6. I multiply 3 times 6, 3 times 6 times 3 rather, it's 18, remainder 1. 6 times 1 is 6. Okay, 6 plus that one which remained, 78. Weird mathematics, eh? So I figured out to say, actually 6 can go into 13 can go into 78 6 times. Okay, what other number can I use as an example? Let's say I'm trying to find how many times what number can I use as an example? Maybe someone can utilize this method. Let's say 56. I'm trying to figure out what number. Okay, let's say, what is 78 plus 26? Okay, plus 26, we're going to have, let me show you another example. There you're going to get 14 and 1. 2 plus 7 is 9. Okay, let's use 13. I don't want to go to 100. Let's use 13. This will give me 11, and then 1 plus 7 will give me 8, plus that one is 9. Okay, I'm trying to see whether how many times 13 goes into 91. Okay, so I'll put a 13 here. Then I'll ask myself, what number can I multiply this 3 with to give me a number whose last number has a 1? Okay, I'll now notice to say 7 multiplied by 3 is 21. Okay, so I'll try now using 7. 7 times 3 is 21, remainder 2. 7 times 1 is 7, plus that 2, 9. So I figured out to say 13 goes into 91 7 times. So sometimes that's how I do math. So like I said, do what works out for you. If this also works for you, by all means use it. Okay, so meaning here, what are you going to get as your speed? So we're going to say, let's check up here. Did you do the right thing? I feel like the speed is too little, but let's first confirm what we did up here. We did 2 into 26 is 13, 2 into 15, that is 7, remainder 2. 2 into 16 is 8. Okay, we have 7, 8 divided by 13. So I'm now going to say 78 divided by 13. That gives me, what did we find? We found 6, huh? We found 6. Okay, this is supposed to be 600 knots, I think. But let me just properly divide so that I can be able to find the correct value. I think I've missed it somewhere. Okay, so we have 1560 divided by 26 hours. Okay, I'm seeing someone saying 2 into 15. 2 into 15 goes there 7 times. Oh yes, 7 times, remainder 1. Okay, let me just quickly redo this. We have 1560, okay, divided by, that was at 26 hours. So 2 into 2 is 1, into 6, that is 3. 2 into 6, that is 3. Now we divide 1560 divided by 2. 1560 divided by 2. 2 into 15 goes there 7 times. 2 times 7 is 14. Remainder a 1. That gives us 16. 2 into 16 is 8. And then we take up the 0 there. So meaning we have 780 on top, which is correct. And then 13 into 78 goes there 6 times. Okay. Then we add our 0 there. So meaning this should give us 60 knots. Okay, I think that is what my math is telling me, 60 knots, unless I am mistaken somewhere, but that should be 60 knots and not 6,000 knots. Yeah, 600 knots. I think I've solved this question before, and I think someone attempted to correct me and they said it's supposed to be 600 knots. I think that's why I was getting it mixed up. Otherwise, the correct way is this. This is our correct answer, 60 knots, and we are done. Problems of having photographic memories. You remember almost everything you see. Okay, so what I was remembering kind of wanted to interfere, actually did interfere with this session. So there your speed is just 60 knots. Okay, and we are done. All right, we now come to the next one. If the local time at A is 10:30, find the local time at B. Okay, at A, okay, A, it is 10:30, and remember A is on the prime meridian, which is 0 degrees. What is the local time at B, which is on 30 degrees west. So here we're going to use our formula for finding the time difference, which is going to be TD is equal to theta over 15. We said the time difference comes from the difference in longitude between the 2 points whose time you are calculating. So we have A and B. A is on 0 degrees, B is on 30 degrees west. So automatically your theta becomes 30 degrees. Okay, because it's going to be 30 minus 0, right? Here there's nothing like, no, we check whether they're in the same hemisphere. You simply subtract or add. Oh no, you don't simply subtract or add. You simply capture the coordinate for the other point compared to the one on 0 degrees. Okay, that is the key there. So automatically our theta is 30 degrees and then divided by what? 15. So the time difference therefore would be equal to 2 hours between A and B. Now what are they saying? The time at A, okay, at A is 10:30. Find the local time at B. So the first thing is check which one is ahead in time, A and B. This is the eastern side. So whatever point is nearest to the east is ahead in time. So A is ahead in time. We now need to find the time at B. So I need to go back. Okay. So since we're going back, what do? You subtract. So you get that time difference, subtract it from 10:30. That will give you the time at what? At B. So I'm now going to say 11, that is 10:30. We now go back to grade 7 again. 10:30 minus 2 hours. So we're going to say 0, 2 hours. Subtract 0 minus 0, 0, 3 minus 0, 3, 10 minus 2. You can simply say 10 minus 2, or you can get a 1 from there. You make this one 10 still. Okay, so at that point it doesn't matter. You can simply say 10 minus 2 there, it will give you 0.8 hours. So meaning the time at B is going to be 08:30. So now another thing you can check is you compare the two timings you have found. This one is ahead in time, so the time should be ahead. Okay, 10:30. Here it's what? 8:30. So otherwise that is that, and we are done with that one. We go to the next one. So now for this one, they are saying the diagram below shows the position of towns A, B, and C. And if you can notice, all those 3 points are on the same longitude. And they are saying what is the time at A if it is 05 hours at B. So here, what you simply apply is that information I gave you the time I was teaching you how to find the time difference. I said for any points lying on the same longitude, I even gave you an example of Harare being the time zone we use here in Zambia. I even said we are most likely on the same longitude as Harare. So now A and B are on the same longitude. You can see that. So if it is at 05 at A, meaning even at B, it is 05 hours. No need for you to start solving anything here. You just need to know that any points on the same longitude have the same time. So meaning at A, B, and C, they have the same time. Alright? You are done. Okay? So sometimes just these small pieces of information is what the examiner will capitalize on. Does this person know that the longitudes, points on the same longitude have the same time? And then if you don't know, you start trying to calculate, and then you find things are not adding up. Okay? We're done there. So now there are also types of questions where you've noticed the past few questions we've solved. They are asking us to find speed, and then they would give us the time and the distance. But then there are cases where they'll ask you to find the speed, but they don't give you the distance. What does that mean? You need to find the distance on your own. Look at this question. A plane flew from town A to town C in 5 hours. What is the speed of the plane in knots? You notice here that they've only given us time, not distance. Why haven't they given us distance? They know to say you should be able to find the distance on your own using the diagram you've been given. So distance formula in paper 1 is this one, theta times 60. As simple as that. What is my theta here? The theta is derived from either the longitudes, the difference in longitudes, or difference in latitudes, depending on the points whose distance you're trying to find, the position of the points whose distance you're trying to find. So if the points whose distance you're trying to find are on the same longitude, it simply means the theta here will come from their difference in latitudes. If the points whose distance you're trying to find are on the same latitude, then the theta will come from their difference in longitudes. So here we're calculating the distance between points A and C. These are on the same longitude, therefore theta will be their difference in latitudes, which is going to be 60 and 30 degrees south. Alright, those are in different hemispheres. Here we have north, here we have south. What did we say? When they're in different hemispheres, you add. So it's going to be 60 plus 30, that gives us 90. So we're going to say 90 times 60. As simple as that. Distance will therefore be equal to, what is 90 times 60? You can simply say, what is 9 times 6? 9 times 6 should give us, what do you get? So here, again I said you can do this trick, 6 times 6. What does that give me? 36. Then again say 6 times. And then you are going to ask yourself, what can I add to 6 to get 9? I can add a 3 to 6 to get 9. So I'll put a 3 there, and then I multiply. What is 6 times 3? That gives me 18. When you add these two values, the key is you need to find 9. Alright? Once you've done that, simply add these values you have on the right. What is 36 plus 18? Alright? 8 plus 6, that gives me 14. Remainder 1. 3 plus 1 is 4, plus that one, 5. So I know to say 6 times 9 is 54. So at this point, I'll simply say 9 times 6 is 54, and then I can add those two zeros, this one and that one, and you are done. So now this is distance. Distance is in what? Nautical miles. So you're going to say nm. Now that you have found the distance, you can now find the speed. So we can say, what is the distance? 5,400 divided by what is the time? The time was given as what? 5 hours. So our speed is going to be equal to, what is 5 divided by 54 divided by 5? So you're going to say 5 into 5, that is 1. Okay, then 5 into 4, it can't. What do you do? So let me do it using the long division method so that we don't mess up here. So we're going to do it this way. That is 5 divided by 54. 5,400. 5 into 5, 1. 5 into 4, it can't. You add a 0 there, you add the next value, it becomes 40. 5 into 40, that's 8. Then you can add that 0 there. So meaning your speed is wait, have I messed up or I have done the right thing there? Is that correct? Yes, I think that is correct. Wrong division, I would die right. So do what works for you. By the way, make sure you confirm your values. This is short division. Let me do long division. I was very good at long division, except it was a very short topic in grade 7, and then I was upset when it ended. 5 into 5, 1. 1 times 5, 5. Subtract, get a 0, bring down a 4. I remember I got this question wrong once, so stuck to me. 5 into 4, it can't. When it can't, you put a 0 there, bring down the next value. Once you bring down two values at the same time, you need to add a 0 up there. 5 into 40 goes there 8 times. Kukasara 0, just add it to your final answer. So meaning we know it's going to be 1080 there. So our speed is 1080 knots. So the examiner here will just trick you by doing this, so that you just say 180 and then you lose it. Alright, so remember, do what works for you. So sometimes they'll give you a question and then they will ask you to find speed, but they won't give you the distance. So that's how you find the distance. Theta times 60, that's your formula. Okay, then we come to the next question. How many do we have left? 2. more questions. Okay, next question says towns A and B are on longitude 75 west and 45 east respectively. Find the time difference. What is the formula for finding the time difference? TD is equal to theta over 15. Here they're not asking us to find time, but simply the time difference. Okay, we said, where do you get the theta from? Your focus is on longitudes. That's why in this question they just gave you longitudes. They're saying towns A and B are on longitudes that and that. No latitudes given, because they know to say when you are calculating time, your focus is on longitudes. So we have 75 west, 45 east. They're in different hemispheres, so we need to add. So we're going to say 75 plus 45. What are you going to get? 5 plus 5 is 0, remainder 1. 10, remainder, you write a 0, remainder 1. 7 plus 4, that is 11, plus that one, 120. Okay, so meaning the time difference will be equal to, I think we solved this some time back. Okay, 15, 120 divided by 15, that gave us 8. In case you have forgotten, this is what we did. We said, we used the 5. 5 there, 3. 5 there, 2, remainder a 2. 5 into 20, 4. Meaning we're going to have TD as 24 over 3. 24 divided by 3 is 8. So your time difference is 8 hours. Remember, they are not asking us to find time, just a time difference. So you are done there. We now go to the next one. An airplane took 4.5 hours to fly from town P to town Q. Find its average speed. Okay, average speed, the formula is simple. It's the same as the one for distance. Average speed is just simply distance over time, or total distance if you like. Total distance taken over total time taken. When you go to speed time graph, it's the same formula as well. Distance is equal to average speed is equal to distance, total distance taken over total time. So now in this case, what have they given us? They've given us time. You can see there's hours there, so meaning we need to find distance. So what are the 2 points? P and Q. Okay, P is here, Q is there. How to find the distance? We say distance is equal to theta times 60. Okay, so the 2 points are on the same longitude. Okay, they are on the same longitude, 75 west. So meaning the theta will come from their difference in what? Latitudes. So what are the latitudinal coordinates? We have 0 and 45. Automatically we are going to pick what? 45. So distance will be equal to 45 times 60. What are you going to get? You multiply 45 times 60. Don't do math mentally, especially in paper 1. 0 times 5 is 0, 0 times 4 is 0, 6 times 5, that is 30. Write a 3, remainder 1. You put a 1 there. 6 times 4, that is 24, plus that 3 there will give you 27. So what do you get? 0 there, 0 there, 7, 2. So you get your distance as 2,700. So the distance we found is 2,700. What is the time? Okay, the time has been given to us as a mixed fraction. How are we going to solve this question? So the examiner here again was just trying to be creative. That's how they gave you time as a fraction. So 4.5 hours. We need to convert this one to an improper fraction. You're going to say 4 times 2 plus 1. 4 times 2 is 8. 8 plus 1, 9, over the same denominator, which is a 2. So what you're now going to have is 9 over 2. So 9 over 2, which is the same as average speed is equal to 2700 divided by 9 over a 2. This is the same as that. So this type of equation is easier solved when you write it like that, so that you can now say over 1 and then you apply the KCF, keep change flip. You keep the first fraction the way it is as 2700 over 1, and then you change that sign to multiplication, and then you flip these values. The bottom one goes up and vice versa. At this point, you now notice that 9 can actually go into 27, so you can now reduce those values. You can say 9 there, 1, 9 into 27 is 3, and you're going to have 300 times the 2. We can just get rid of these ones down here. So average speed will therefore be equal to 600. This is average speed, so it will also be knots. And you are done. Okay, as simple as that. Then we're going to say, this is our last question. In the following diagram, points A and B lie on latitude 60 degrees south. In the following diagram, points A and B lie on 60 degrees south, while point C is on latitude 30 degrees north. Okay, just clean up. Okay, while point C is on latitude 30 degrees north. The local time at A is 10 hours, when it is 13 hours at B. Find the difference in longitudes between A and B. Very simple question. Okay, time difference is equal to theta over 15. What are they asking us to find? Find the what? The difference in longitudes. Okay, we said when you're dealing with time difference, where do you get this theta? From the difference in what? Longitudes. So here we're just trying to find the value for theta. We can find the time difference by subtracting these two times, 10 and 13 hours. When you subtract these two, 13 hours minus 10 hours, it will give you what? 3 hours. That's the time difference. So where there's TD, put 3. Okay, you're trying to find theta over 15. Then you can say over 1, cross multiply. 3 times 15, what do you get? 15 there times 3. 3 times 5 is 15. Remember 1. 3 times 1 is 3 plus 1, 45. So you're going to have 45 on the left, and then you have theta here, and you are done. As simple as that. Are there any questions there? Do I need to explain any further than that, or have we understood? Is that clear? Or are people still processing what I've just done? Okay, I need some feedback. Have we understood how to solve that one? Okay, I'll take the silence as confirmation that people have understood. All right, otherwise, if not, please make mention so that I can explain some more how I have solved that one. Okay, we go to the last question. A plane, okay, great, thank you for that feedback. A plane flew from B to C at a speed of 600 knots. How long did the plane take? You see now the examiner, okay, it's just me now because of how I arrange these questions. Okay, so there are cases where they ask you to find speed, they just give you maybe, or they ask you to find one of those values, those 3 values in this formula, but they don't give you the distance. So here they've given us speed. Okay, speed as 600 knots. Time is not given, distance is also not given. What are they asking us to find? How long did it take? How long simply refers to time. So we need to find distance first. What points do we have? B and C. B and C. We said distance is equal to theta times 60. So distance will be equal to, what is your theta? Your theta is going to come from the difference in latitudes. So north, south, we add 60 plus 30, that's 90, times 60. We multiplied this value recently, and that gave us 5400. Not commas. You remember where I was doing 6 times 6 gives us 36. Then I said 6 times what number can I multiply with to give me a 9 there? That would be a 3. And then that gave me 18. And then when I added, I said 5 plus 6 gives me 14. Remainder 1 there. Oops. Okay, gave me remainder 1 there. 1 plus 3 is 4 plus that one, 54. I still remember that value. So that's our distance. Now they're asking us to say how long did it take. So they've given us speed and we have now found distance. So speed they gave us as 600, distance we have found 5,400. We are required to find time. So we're going to say over 1, cross multiply. What is that going to give us? It's going to give us 600t is equal to 5,400. Then you divide both sides by 600 by 600, so that these guys cancel, remain with time here. These guys can also cancel. 54 divided by 6, you remember that it is still going to be 9 hours since this is time, and you are done. At this point I can say you are ready for Earth Geometry paper 1. Do you have any questions? Do we have any questions? Is it clear? Okay, that's nice to know that it is actually clear. So now we are remaining with one more session, which is going to be okay on A. All right, so let me just quickly look at A again. So A, this is what we've been told. In the following diagram, points A and B lie on 60 degrees south, while point C is on latitude 30 degrees north. They're just describing the diagram. The local time at A is 10 hours. When it is 13 hours at what? At B. Find the difference in longitudes between the points A and B. So here is what the examiner has done. Instead of asking us to find the different times for these 2 points, they have already given us the times. Alright, now they're asking us to find the difference in longitudes. Imagine they didn't give us the time. What we're going to do, we're going to use this formula, and then we're going to say the theta here will come from their difference in what? Longitudes. But then they've already given us the times. So the times we've been given, we can be able to figure out the time difference by subtracting the timings. So we're going to say 13 hours minus 10 hours. That will give us what? The time difference. So when you subtract there, you're going to get 3 hours. That is your time difference. So all we have to do now is convert this time to what? Degrees, which is going to give us our theta. Remember we said the theta comes from the difference in what? The difference in degrees, in longitudes. So what we are doing here is this. When we are finding the time difference, imagine you have 2 points and you've just been given the time for one. The process is this. First find the time difference, okay, of which the difference in longitudes is also involved. So here all you are trying to find is theta, when you already know what? The time difference, because we know now that the time difference is what? 3 hours. So where there is TD, I'll put 3 hours, and now I can calculate for theta. Alright, so when I cross multiply, it's going to be 3 times 15. That will give me 45 degrees. Therefore the difference in longitudes is going to be 45 degrees, because we said in this formula TD, our theta is a difference in longitudes between the 2 points whose time we're trying to calculate. So that's how we solve that one. Is that clear? Okay, that's good to hear. All right, so we now we're remaining with one more session which is a speed time graph. It is quite a long session. It will take us some time. So my time is currently 18:32, and I know to say people have to eat, so I'm okay with continuing, but I need to hear from you people. Are you going to be available from now until we finish, or you need to eat first, so that maybe we can push it to a slightly later time? if that is okay with everyone in the house. I'm okay with us continuing, going on a short break again of 10 minutes and coming back to finish up. But I'm also trying to consider other people. We have parents here that need to facilitate supper for their dependents and all that, their husbands, such things. So are we okay to continue, or we can take a break? Now here are the parameters. If we take a break, I have another session at 20 hours where we're going to be yes, exactly, Mr. Mwape. So we are going to have a session at 20 hours where I'll be revising mathematics paper 1 with the main class. You are free to jump on board, you people that have actually signed up for the crash course. Our goal in that paper is basically to revise I'll try to revise as many questions as I can with them. So you can also jump on board. That is free invitation from some of you who are not my students who have just signed up for this crash course. So you're free to jump on board. So meaning if we take a break, we can only resume at 20 hours. Okay, because that session will roughly take about an hour with the main class. So meaning at 20 hours, that is when we'll switch to our crash course, which is going to be speed time graph. So which option are we going for? We continue and finish, we call it a night, or we go on a break, we do what we need to do, we have our supper, and then if we are able, we jump on board that class at 20 hours for the revision of paper 1, which I would highly recommend. And then after that session, we can now switch to linear program, what is speed time graph as a topic on its own. Of course, I'm likely to revise this one also with them. So which one are you going for? We have how many people in the class? Okay, I can see Madam Chimia says she'll join at 20 hours. Okay, anybody else thinking in those lines? Please let us vote. All of us need to say something here. We don't want to inconvenience anyone. Then we'll go for what the majority will say. Okay, 20 is okay. Okay, I have 3 more people who need to give their inputs. Okay, we have 3. According to chairmanship, 20 hours wins. Okay, in case you won't be available at 20, I'll still record the session. In case you won't be available for that particular session, I'll still record and you can still be able to watch it at a later time. As you've noticed, I try to simplify explanations as much as possible, such that even when it comes to a recorded video, you almost be able to grasp the concept and you probably have no or fewer questions. Okay, so at 20 hours, I'll share the link with you again for that revision for the other class. Then immediately after, we'll go on a short break and then we'll switch to our lesson on speed time graph. So otherwise, that is that. Thank you for your time, and I'll see you again this evening.